Hello and welcome to this video in which we're going to look at the ANOVA practice activity that we set during the Staturday. So this is the practice, the additional practice option that I provided. So if we open this up, what is it asking us to do? It's asking us, with the data called exam conditions, it's asking us to identify an appropriate two-way ANOVA to perform. Why are we doing that? So we're going to base that around our research design. We're going to look at the assumptions for running ANOVA, consider whether we've met them or we violated them. If we violated them, what are the implications of that? Consider any issues with the data or the analysis that we might need to look at. So we can consider that. And then we'll look at the preliminary results of the ANOVA, and we'll look at something called the main effects and the interaction effect to understand what's going on. Okay, so this is what we're going to focus on today. So the data set here is exam conditions data set, so we'll get that open. So when the data set opens, what we can see is we have our data set here, and we also have an output file. So this at the top is a log of everything we do to the data, and then if there are analyses, these are produced underneath it, so it keeps a useful log of your activities. If we just look at this, so what we can see, we have one IV here, which is the revision IV. So we've got revision in sitting rooms and revision in an exam hall, and you are either allocated to one here or the other. So you're in either the sitting room revision group or the exam hall revision group. So this would be a between subjects element. The next thing we can see is that everyone, so each of these rows represents one person, everyone has a score for an exam in sitting rooms and an exam in an exam hall. So everyone took part in both of these conditions. So this is a within subjects or repeated measures element. So what this can tell us is we've got two IVs, revision conditions, exam conditions, one DV, which is the exam score, and we're looking at comparing between the two revision conditions, between the two exam conditions, and whether there's an interaction between the two things. So for this we can tell we need to do a mixed methods ANOVA. So the first thing we need to do is to consider the type of analysis we want to do and the type of data. Do we meet all of the assumptions for that? So the walkthrough you could be using to guide you would be the two-way mixed methods ANOVA, so I'll open that up. So with the walkthrough, this is obviously a different scenario, but you could use this to help guide you as to what you need to check. The difference with the walkthrough example is there are 3 levels of time, but we've only got 2 within subjects levels. An IV, sorry, with two within subjects levels, so it's not going to be completely compatible with this example, but it would be a useful guide to at least point you in the right direction. So looking at the data we've opened, what we need to do first of all is to check that our data is normally distributed. So we go to Analyze, Descriptive Statistics and Explore. We need to transfer our between subjects variable into the factor list. This is because we need to look at the way that scores are distributed for each of these groups on these 2 variables. So we click on those and transfer those into the dependent list. Now we can leave the statistics options and the options in the default settings as they are. I'll just quickly look at options here. So we have complete data, but if we had missing data, we would need to make a decision as to excluding that list-wise. So if someone had data missing on one of these variables, then we would have to exclude them across the whole thing, or pairwise. So we include them where they do have data and exclude them where they don't. So you'd have to make a decision as to which of these is the most appropriate. As I said, we have complete data, so we'll cancel that. The options we do need to change are in the plots function. Currently just stem and leaf plots are ticked, but we'll also want our histograms and our normality plots with tests, because we need to look at what our data, how it appears. So we'll click continue, we'll click OK. You can see our log is being added to there. Let's open this up a little bit more. So what we can see here is a sort of index of everything we've got. We'll look back at explore, is the function we ran. So we can see in this case processing summary the number of cases, which in this instance are our participants, who were in the sitting room condition, and the number of participants we have in the example condition in terms of the data for both of our dependent variables. And what we can see here is that we have 20 people in each of those conditions, and we have no missing data, so that's a good sign. So the first thing we'll want to do is look at the mean and the trimmed mean for each of our subgroups and each of our subconditions, as it were. And we want to see these two values are roughly the same. Now the reason for that is this is the mean. The trimmed mean is when we have cut off the two tails of our distribution. So if you imagine a bell curve, we've cut off the 2.5% of those scores at the extremes of either end of our distribution. If there's an outlier, what that means, an extreme value, if we cut that out, what you'll see is a drastic change in the mean compared to the trimmed mean. We can see here in this case they are not that different, so that probably implies there isn't an outlier, but we would follow this up by looking at things like our box plots to make sure. We're also going to look at the skew and kurtosis values. Now, as a very rough rule of thumb, if this is within plus or minus 1, then there's usually nothing too concerning, but that is a very rough rule of thumb. So this looks okay, but we would back this up by looking at our histograms and our box plots and our tests of normality. So we would look at that for each of the subgroups on both dependent variables. What we can just see here, just to point this out, the revision in example group on the exam sitting room scores, there's more skew for this variable, so this is negative skew. So we might want to look at that further. But as it is, you would look through each of those and you would look at whether there are any problems. The next thing we'll look at the test of normality. Now you can use technically either of these, but if we have small samples, the Shapiro-Wilk test is more reliable. So a small sample is one that has 50 participants or fewer in it. That's usually how it's classified for this. So in this case we only have 20 participants in each of our conditions, or subconditions. So the Shapiro-Wilk would be the safer one to use, and you can see that that does have an impact. If we use the KS test, this variable here for this group would be non-significant, but when we look at it in this table, it's statistically significant. So if you have a value in here of 0.05 or less, what that implies is the distribution is statistically significantly different from normal. If it's different from normal, you have violated the assumption of normality. These tests can be overly sensitive though, so what we need to do is make sure we've looked at all the evidence before we form a conclusion. So the next thing we'll look at are our histograms. Now, to help us, what we can do is add something called a normal distribution curve. So we can double click anywhere on the graph and it will produce the chart editor. To fit a normal distribution, what we need to do is just click on this button here, show distribution curve. Now, normal is the one that is the default setting, so this is fine. We'll click close. We'll close this down. And what we can see now is our chart with a normal distribution curve fitted to it. And there's nothing too concerning here, so it roughly follows the normal distribution. So for this, there's nothing too concerning. But we'll look at the next variable. Now we can see here there's a potential problem. There is quite a lot of skew present in this variable. Now the tail of the distribution is towards the lower end of the scale, so that is negative skew, and that fits with that value we looked at earlier. Now if this was your research, you would need to make a decision around this. Is this deviation from normality substantial enough to warrant concern? If it is, there are a few options open to you. You could look at transforming the variable. So that's where you apply a mathematical formula to every data point in the variable, which in the data set, sorry, for this variable, which can change the spread, the distribution, and it can fix the problem, but quite often it just makes it worse or breaks it. But if you want to learn more about transformations, I'd recommend reading the Andy Field book, Discovering Statistics Using SPSS. The alternative usually is to, if there are concerns around normality and we have a smallish sample size, then what we might want to do is consider running a non-parametric test instead. Now the issue is there aren't non-parametric versions of a two-way ANOVA. So what you'd have to do is break it down into separate things and run the non-parametric tests that are available. So you'd have to look at probably your between groups elements first, then your within groups elements separately, and so on. So it becomes more cumbersome, but there are ways around that. Tabachnik and Fiddle also talk about if you've got balanced groups where you have at least, I think, around 20 people in each cell of the design, then sometimes we can suggest that it should be fairly robust against moderate violations of normality. Now, a lot of the statistics across this seem to suggest that it could be a moderate deviation from normality, but you would need to make that decision. And what it is evidencing the choice you've made, drawing on relevant guidelines to show that it's an appropriate approach to take, and taking it from there. So I would leave that with you as to consider what that is. The implications are that if you have data that doesn't meet the assumptions, you're less confident in your findings. It could be something to do with the way that the data is distributed that could produce what looks like differences between groups, but actually is purely about the way that the data is distributed and not the treatment effect that you're looking at. So that's the risk. Okay, so that's the potential implications of a violation here. I would let you decide at this point, but we're going to continue with the analysis so that we can see what the two-way ANOVA looks like. Okay, but you would need to make a decision at this point. So we would look through the rest of the information, including our box plots. So we would do this for every one of these subgroups. What we're looking for in the box plot, ideally what we want to see is this nice line here in the middle. So this represents the interquartile range. This is the median value. And then we have the tails. Now, if it's a normally distributed variable, what we would have are equally long tails. As I said, this line in the middle, and we wouldn't see any circles or asterisks above or below these lines. So if you see a circle or asterisk, what that indicates is the presence of an outlier, and you would need to look at that further. So you need to understand why it was an outlier and consider how you might handle it, because things like ANOVA don't handle outliers very well. Okay, so I will let you check through the rest of that and make a decision. But we're going to run the ANOVA just to get a feel for it. So if we go to Analyze, what we're looking for the general linear model. And because we have two independent variables and one of them is a repeated element, we're going to use this option here, repeated measures. So our within subjects factor name, well, that is actually the exam condition that we've looked at. Okay, so we're looking at an exam condition. Everyone took part in two exam conditions. One of them is the sitting room exam condition, and one of them is the exam hall exam condition. So we're going to call this overarching variable exam condition. And as I said, that only has two levels, sitting room and exam hall, and I will add that. Next we need to define what that means, so we're going to click on define, and we're going to transfer these across. So this represents our dependent variable measured in each of these two levels of exam condition. So we highlight those and transfer them over. We've got our between subjects element 2 though, so this is where people revise, so they either revised in a sitting room or they revised in an exam hall. So we're going to move that to a between subjects factor box here. Now if we had more than two levels for either of these, what we would need to consider is running a contrast. So usually a contrast would be applied to the within subjects effect. which would be exam condition. We don't need to do this, as I said, because we only have 2 levels. But if you had 3 levels, you'd need to consider the type of contrast you want to run. Again, I would look at the Andy Field book for further guidance on that, because there are lots of different types and they tend to be used in depending on different circumstances. But we don't need that for now. If we had our between subjects effect had more than 2 levels, then we would also need to consider a post hoc test. So again, this is the revision IV. If we needed post hoc tests, we would transfer this over and we would choose the most appropriate approach. So in this case, you might choose the 2 key, which is one of the common ones used, or so on. We only have 2 levels, so we don't need to do that. If we find a difference between, based on revision IV, the revision IV, we know it can only be between those 2 levels, so we wouldn't need to look any further. Now we need to look at the plots. So plots are a really useful tool, particularly for helping us understand interactions. So I'm going to ask for a plot to be produced. I'm going to ask for exam condition to be displayed as separate lines on the graph, and revision IV, I'm going to ask for that to be displayed as the units on the horizontal axis, the x-axis. So I'll add that. And that's important. You can do this in whatever order makes most sense. So you can play around this to get the most useful graph. But this is the one we'll stick with. So we click continue. Now there are different options you can choose in here that help you understand things like error in the model, that help you understand univariate or multivariate outliers and their potential impact. So if you'd like to learn more about that, have a look at the Andy Field book, but I'll leave that blank for the moment. Or actually we can tick the Cook's distance, we'll look at that. Click continue, and then options, the final thing. So what we want to do is transfer all of this over, so we have means for each of these things. We want our descriptive statistics, we'll ask for estimates of effect size, and we want our homogeneity tests as well. Okay, so this is one of our assumptions we need to check. There are other things again, but I'll let you consider whether you'd want those or not. We click continue, and now we click OK, and this will run the ANOVA. Okay, so our output for ANOVA starts here. The within subjects factors box just tells us how our within subjects IV has been labelled up, what that means, so you can check that you've done that appropriately. The between subjects factors just tells us again how people have been labelled up, make sure that we've got the cases within the conditions we expect. So the next box is our descriptive statistics. We can eyeball this to start with, just to get a feel for it. We can see overall the exam condition in the sitting room has got a slightly higher score than the exam in the hall condition overall, but we can break that further and compare between them. So there seems to be quite a difference between revision in the sitting room and revision in the exam hall on scores for this variable. But whether or not any of that is statistically significant, we won't know until we analyse the data further. This next box here, the box's test of equality of covariance matrices, this is an important one to look at, but it can be extremely sensitive. So as long as this value is greater than 0.001, we would say that it isn't statistically significant. It's not a cause for concern. If you violate the assumption, so that value is less than 0.001, as I said, this can be very sensitive. So as long as you have equal groups, the usual argument is that we can ignore this, because we can be fairly robust to these issues if we have equal numbers of people in each group. If you don't have equal numbers of people in each group, so perhaps we had 20 in one and 10 in another, this could be a problem if that was violated. Okay. Okay, so the next thing we want to look at we'll look at the Mauchly's test of sphericity now. You can see here you've got a dot, and that's because this is only relevant if you have more than 2 levels for your within subjects IV. We've only got 2, so it can't be produced, therefore we can ignore it. But if you had more than 2, you'd need to make a decision. So in this case, what we can do is we can interpret the sphericity assumed statistics, and we can not worry about any of the others. Okay. What we can see here, we have different rows. So in the exam condition, that's our 1 IV, our within subjects IV. And this is the interaction then between our exam condition variable and our between groups variable, the revision IV. So this is a main effect of the exam condition. This is an interaction term. What we can see here are the significance values. So if this is 0.05 or below, then it's statistically significant. This is greater than 0.05, so this is not significant. There's no main effect for exam condition. But what you can see here is there is an interaction between exam condition and revision IV. And this value is much lower than 0.05. It is highly statistically significant. And we've got a measure of effect as well here that gives us an idea of the size of it, so you can get some guidelines as to what's a small, medium and large effect. And you can apply that to get a feel for if it's statistically significant, how practically useful is it as well. Okay, so exam condition by revision suggests that there is an interaction between these two variables. Next box we're going to look at is the test for equality of error variances. We want this to be not significant, so we want this value to be greater than 0.05 for both variables. It is, so we haven't violated the test of equality of error variances, so we can be fairly safe to proceed. The next box we're going to look at here is our between subjects effect, so the impact of revision on its own. What we can see here is that value is less than 0.05, so it is statistically significant. But the issue is, as soon as we've now got this interaction effect, our main effects become much harder to interpret, because we know that it's not just about revision IV anymore. It's not just about where you did your revision. It's how you score in the exam is dependent on then which exam condition we're looking at. So looking purely at just the revision isn't going to tell us the whole story. So we need to be careful when we're interpreting main effects in light of the interaction effect. So our marginal means, what do they tell us? So you've got the grand mean, you've got our revision between groups here, so we can see the difference overall. There is a slight difference. We've got our exam conditions variable regardless of, so just looking at exam conditions on its own, there's hardly any difference here, so that's probably why we haven't found anything going on. And when we separate them out here, we can see the difference between the means. There is quite a substantial difference between these two, the two exam conditions, if you revise in the sitting room. And when we plot that out, this is what it looks like. So the fact that our figure, the lines on our figure cross over, is a strong indication of an interaction effect. And we can see here what the difference is. So if we look at where we did revision, if you revise in the sitting room, and we look at our exam condition here, so for exam condition 1, we can look at how that was labelled. Exam condition 1 is the sitting room, exam condition 2 is the exam hall. So we've got, if you revise in the sitting room, so what we've got here, if you revised in the sitting room and you took your exam in the sitting room, you did very well. If you revised in the exam hall and you did your study in the sitting room, your exam in the sitting room, there isn't too much of a difference between sitting room example, what we see is a huge difference in where you revised for when you're doing your exam in an exam hall conditions. So if you revised in a sitting room and then you did the exam in the exam hall, you scored very poorly. If you revised in the exam hall and you did your your scores in the exam condition were much higher than everyone else. So it would suggest that revising in exam hall to take an exam in an exam hall is going to be the best way of revising, because it gives you the best chance of getting higher scores in that condition. So there is an interaction here, and it's particularly around this issue here. So where you revised when you're doing the exam. Okay, so we just look back at our data set. So we also requested a Cook's distance to be produced. What this Cook's distance does is give us an idea if a case is exerting an undue influence, so it's an outlier and it is exerting an undue influence on the model. What we're looking for here are values of 1 or greater for each of these cases for both variables. So what we'd be looking to do is just to go through and identify if there are any values there of 1 or greater. Just from eyeballing it, we can see that there aren't, so that would suggest there are no cases in here that are an outlier and exerting an undue influence on the data, so that's a good point. Okay, so what we'll do now is we'll look back at that Word document, our practice activity. So we may have identified a violation of the assumption around univariate normality, so you would need to consider that. Were there any issues with the data or the analysis? We didn't identify any in this example, so we had balanced groups, no missing data, and we hadn't violated any of the other assumptions, and so on. We've been able to go through and thoroughly consider the different things that we need to look at in order to check these things, so there was nothing missing from the analysis either. So what do the preliminary results suggest? So we'd look back at our main effect. So there wasn't a main effect of exam condition, but there was a main effect for revision condition, or revision group, sorry. But there was an interaction effect. So this is the one that we'd really need to unpick, and that's where we were looking at our figure. So there was an interaction effect, and it seemed to be that in an exam hall, it matters a lot where you do your revision. And what we could do with that, well, we could consider if we were in a learning and teaching environment, suggesting to students that they make sure, if they know they're doing an exam in an exam hall, to make sure their revision scenario, their revision context matches that exam hall conditions. So there's something about that we need to explore further, but it could be that might be a way of considering using the results. But what we could do to take the research further might be to have interviews with students to identify what the issues were in terms of having an exam in an exam hall and how that differed, whether they revised in different contexts. So perhaps we could explore this qualitatively to try and understand better why we found that effect. Okay, thank you very much.